Click the bell icon to get latest videos from Ekeeda.
So dear students, today we are going to learn about atomic force microscope. So basically what is an atomic force microscope? This is a surface analysis technique which is used for characterization of nanomaterials. Now how does this work? Now atomic force microscope has a very good resolution of the order of 1 angstrom laterally, and vertically also it has a resolution of the order of zero point 0.1 angstroms. Remember, 1 angstrom corresponds to 0.1 nanometer. So you can compare it. Next, the basic thing about atomic force microscope is we do not want any vacuum for its operation. You know that when we are dealing with scanning electron microscope, or we require, or even for example scanning tunneling microscope, we require a very large vacuum of the order of 10 raised to minus 6 or 10 raised to minus 9 torr. One of the biggest advantage where actually AFM scores above all the characterization techniques is it does not require any vacuum for its operation. So the kind of force which it can detect is of the order of 10 raised to minus 12 Newton, that is of the order of piconewton. Remember, 10 raised to minus 9 is nano and 10 raised to minus 12 is pico. For your information, 10 raised to minus 15 corresponds to femto. Now, how does this entire method work of characterization? What we over here too, we have a cantilever. So how does this cantilever work? This cantilever is basically working on the principle of an optomechanical device. We can say that this cantilever is nothing but an optomechanical device. Why do I say opto? Because it is used lasers. Why do I say it's mechanical? It is mechanical because whatever deflections are there, these deflections are being captured in the optical domain. That's the reason why you say that it is a optomechanical mechanism, right? Now coming down to basically the procedure of finding out or rather the resolution of a particular nano surface. How do we do that? What we basically do is we have the tip or rather the cantilever. In this case, it is just not the tip as it was the case for the scanning tunneling microscope. We just don't have only a simple tip, but associated with the tip, what we have is nothing but a cantilever. Now, all of you know that let us say I'm moving, suppose I'm having a surface and I'm moving this tip above this. The minute I'm getting a depression, this is going to move down. The minute I'm getting a elevated surface, this is going to move up. So all these variations in the cantilever are being captured with the help of optics. This means laser is getting incident on your cantilever, and as it moves up and down, the reflected beam is captured by an array of photodetectors which are placed all around the chamber in which this entire thing is located. And depending upon that, depending upon these deflections, you can actually get an idea about the topography of this surface. Now, there are two ways in which the atomic force microscope works. Now, what are these two methods in which this atomic force microscope works? One method is the direct contact method. This is very simple to see. So, in the direct contact method, what happens is you have a tip that is attached to a cantilever and it moves across the surface, and whatever variations or rather whatever deflections are there in the tip, these are being captured by the reflected light, and these deflections are then generated into a 3D image. So this is called as the contact mode of operation. In the second mode of operation, what we have is nothing but one has to say a non-contact mode, or rather it is also called as the tapping mode of operation of the AFM. So what basically happens in the tapping mode of AFM? What happens in this is, remember, in the contact mode, there is going to be a variation in the force. And hence there is going to be a variation in the deflection of the cantilever. In this case, in the tapping mode, which is the second mode in which the AFM works, what we have is the cantilever along with the tip moves across the surface in such a way that the force on it remains the same. Now, how are you going to keep the force constant? You are going to keep the force constant by maintaining a constant distance between the surface and the tip. So when we do that, we are having another way of operation of AFM. And in this mode of operation, as I've said, which is also called as the tapping mode, you are actually allowing the cantilever, or rather you are allowing the cantilever to move only with under a simple strain, or rather a single strain value. You don't allow it to change the value of the cantilever strain. So in this case also, you are actually capturing the topography of the sample. One of the biggest advantages of AFM, that is the atomic force microscope, is this, that you do not need, that it actually works even on wet surfaces. So the force that we are actually acting between the tip and the surface it can be a mechanical force, right? It can be a van der Waals force, or at times it can also be a magnetic force. So all these variations which are there are captured by the tip of the cantilever of the AFM, and all of these is actually captured as a 3D image. And this is how actually students and AFM works. Thank you dear students for watching this video. Please do subscribe to Ekeeda. Thanks a lot.